Okay, hello everyone. So in the last class, we finished up to problem 19. So I'm going to start from question number 20, and I'll try to go over all the problems and record it and post it on the YouTube. Okay, so the test statistics in a right tail test is z equal 1.69. Determine the p-value and decide whether at the 5% level of significance the data provide sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis. So that's when we have to find the p-value. And here the test is right tail test. So if we draw the normal curve, it's and our test statistics is z equal 1.67. So this is our test statistics, which is 1.67. So we have to find the p-value. So this area is the p-value. So the area for right tail test, the area on the right side of the test statistic is the p-value for our right tail test. So that's mean actually we have to find the probability of z greater than 1.67. Okay, so we are given the z table. So let's look at the z table under the normal curves. Okay, so this is positive value, so we can just look at negative value, then we'll directly get the p-value. Okay, so our test statistics is 1.67. So look at negative 1.67. Then you will directly get the p-value since the distribution, normal distribution is symmetric. So 1.6 is here, negative 1.6, and 7 is, this is 0, 1, 2, 3, 4, 5, 6, 7. So this is 7. So that's mean for negative 1.67, the p-value is 0.0526. Okay, the p-value is 0.0526. So we found the p-value is 0.0526. So this is our p-value. Okay, so let me plug in the p-value here and round to 3 decimal places. So 0.05, it should be 3. Okay, so let me check the answer. Yeah, that's not correct answer. Okay. How about 2? Okay, so let me check again. So this is area 1.67. Oh, okay, I did mistake actually. So they started from 0.9 to, so these decimal places from larger to the smaller. So, but when I found the p-value, I considered 0 to 0.9. So actually it should be 1.67 should be 1.6 is here and 7 is here. So 1.67 is here. So it is 0.0475. So that means 0.048. So 0.048. Okay. Let me check the answer. Yeah, that's correct answer. So the p-value is alpha is, now the alpha is 5%. So that's mean this is 0.05. Then the p-value is less than the alpha value. So we reject the null hypothesis, right? When p-value is less than the alpha value, we reject the null, and the data provides, the p-value provides sufficient evidence to reject the null, right? So it should be the p-value provides sufficient evidence to reject the null hypothesis because it is less than the significance level. Yeah, so let me check the answer. Yeah, that's correct. So the test statistics is in a right tail test, z is equal negative 0.81. Similarly, you have to find the p-value. So look at the table. Okay. negative 0.81. So that's mean now okay, negative, this is also right till test, right? 0.81. So that's mean we are looking for this area. So now if you look at negative 0.81 in the Z table, you will get this area. So that's mean if you look at this number, then you have to do 1 minus the area for this number. Or what you can do, you can look at 0 in the table, you can directly look at 0.81. Then you will get the area, you will get this area. Because if you look at 0.81, you will get actually area from here to here, and which is same as the area from here to here. Okay, so let's look at 0.81. Yeah, 0.81 is, this is 0.8 and this is 1, so the area is 0.791. So the p-value is 0.791. Yeah, let me check the answer. Yeah, that's correct. Okay, so let me erase, clear everything. Okay, so now the p-value is way more than the significance level, all right? So that's mean the data or p-value doesn't provide sufficient evidence to reject the null, as the p-value is greater than the significance level. So we cannot reject the null. Yeah, next problem is a sample mean and sample size. So we are given the sample mean, sample size, population standard deviation are provided below. Use the one mean z-test to perform the required hypothesis test at 1% level of significance. So here the test is left tail test, right? Because our alternative is mu less than 27. And level of significance alpha is 1%. So it is given that alpha is 1% here, right? This is 1%. So alpha is 1%. So that's means 0.01. Okay, so now we need to calculate the test statistic. So this is z-test. So to calculate the test statistics, you need to do x bar minus mu 0 divided by sigma over square root of n. So here the x bar is 24 minus mu 0 is 27 and sigma is given, which is 6 over square root of 40. So you need to simplify this one and you will get the test statistics. So let me simplify, get the calculator and simplify this one. Okay, so after simplifying this, I found 24 minus 27 divided 6 times square root of 40. So I found negative 3 point negative. So I found negative 3.16227. But how many decimal we need? We need 2 decimal places. So that's mean negative 3.16. So here we have the test statistics is negative 3.16, negative 3.16. So let me check the answer. Yeah, that's correct answer. Okay, so identify the critical values, select the correct choice below and fill in the answer box within your choice. So now we need to identify the critical value. So since this is left tail test, so the test is left tail test. So the critical value will be on the left tail and this is negative z alpha. Okay, so let me clear everything first. So this is left tail test and our alpha value is 1%. So this is 0.01. So we need to find z alpha, negative z alpha, and this area is 0.01. So if you look at the z table, so you can get the critical value. So now you have to find the critical value. So from the Z table, you can find it. So it is, I think, negative 2.576 or something. Okay, so let me check whether it is negative 2.576 or not. Negative 2.58. It should be negative 2.58, I guess. Yeah, that's not correct. Okay, so let me check. Actually, you need to find it from the Z table. Yeah, this is negative 2.33. So if you look at the Z table, you will get negative 2.33. Yeah. Oh, I think negative 5.6 is when alpha is 0.005, I guess. Okay, anyway. So we have the critical value. So now we need to the null hypothesis. So we need to make the decision. Okay, so now the critical value is, you can see this is negative 2.33. And what did we find for test statistics? We found Z observed is negative 3.16. So Z observed is somewhere here, right? So that's mean the Z observed is in the rejection region. So we reject the null hypothesis. So we reject the null hypothesis. Our decision should be reject the null hypothesis. So the data provide sufficient evidence to conclude that the mean is less than 27. Mean is less than 27 because the alternative is mean is less than 27. Yeah, that's correct answer. Okay, so the next problem is, this is similar type of problem, but this is right till test. So you need to, okay, so here you need to also do the Z test. Okay, so let me erase all the drawings. Okay. So here we have X bar, we have sigma, we have the alternative. So the alternative is here, mu is greater than 31. So that's mean the test is right till test. So we need to find the test statistics. Z observed, which is X bar minus mu 0 divided by sigma over a square root of n. Okay, so plug in all the numbers. X bar is 34, minus mu 0 is 31, sigma is 5, divided by a square root of 15, right? Because n is 15. Okay, so let's simplify this expression and you will get the test statistics. So after simplifying, I will get 34 minus 31 divided by 5 times a square root of 15. Okay, so I found 2.3237. So we need to round it to 2 decimal places. So it will be 2.32. So the test statistic is 2.32. Okay, so let me insert the test statistic here, and which is 2.32 and check the results. Yeah, that's great. We got the correct result. Now we need to find the p-value. So to find the p-value, look at the Z table. So we have the partial Z table here. So let me clear all the drawings first. Okay, so this is the Z table and our test statistics is 2.32 and this is right till test. So that's mean, okay, so let me draw the normal curve. So this is the area we need to find. This is 2.32. Okay, the thing is that if you look at 2.32, you will get the area of this part. So to get the area of the shaded region, you need to do 1 minus, look at 2.32, 2.3 is here, and second decimal plus 2 is here. So that's mean the area is 0.9898. So 1 minus 0.9898. So this area will be then, the p-value will be then, the p-value will be then 1 minus 0.9898. Okay, so let me simplify this, 1.9898. So this is 0.0102. So this is the p-value. So, but we need to round it to 4 decimal places, and we have up to 4 decimal places. So that's perfect. Okay, so let me check the answer. Okay, so this is 0.0102 and check the answer. Yeah, that's correct answer. And what is the alpha value? Alpha value is 10%, right? So alpha is 10%. So that's mean alpha is 0.1. Okay, so here the p-value is less than alpha. So that's mean the data provides sufficient evidence. So we reject the null and the data provides sufficient evidence to conclude the alternative. So what is alternative? The alternative is the population mean is greater than 31, is greater than 31. Yeah. Yeah, that's correct answer. Okay, so this is two-tail test. So since we went over one to right tail and left tail test, so I think it's better to go over this one as well. Sample mean, so we are given the sample mean, the population standard deviation, and the alternative. So the alternative is alternative is mu not equal 30. That's when the population mean is not equal 30. So that's when this is two-tail test, since we have this sign in the alternative, right? Not equal. So it could be less than, it could be greater than. So it could be on the left tail or right tail. And alpha is 1%, which is 0.01. But to find the critical value, we need negative plus minus z alpha over 2. Okay, so we need this one. That's mean we need to find plus minus z 0.005. Okay. So first we need to calculate the test statistics. Z observed, which is same as left tail and right tail test. Okay, plug in all the numbers. 28 minus 30, and this is 6 over a square root of 21. Simplify this one. If you simplify this one, then it will be 28 minus 30 divided by 6. Okay, I'm sorry. 28 minus 30 divided by 6 and times a square root of 21. Okay, so I found negative 1.5275. So we need 2 decimal places. So that's mean negative 1.53. Okay, so this is our test statistics, negative 1.53, negative 1.53. Okay, so let me check the answer. Yeah, that's correct answer. Okay, so I didn't identify the critical value. So this is two-tail test. So the critical value will be plus minus, I think this is 2.58, I guess, or we can find it from the 2.58. So, or you can find it from the Z table. So you will just look at negative, you will look at this area 0.005, and you will see that the Z score will be negative 2.58. But we need both. We need positive 2.58 and negative 2.58, because for two-tail test, the rejection region will be this tail and also in this tail. So this is negative 2.58. This is 2.58. So this is the rejection region, and this is also rejection region. Okay, so now look at the test statistic. So what is the test statistics? Negative 1.53. This is 0. So this is somewhere here. So that's mean the test statistic is not in the rejection region. So we fail to reject the null, right? Because this is inside this region, not in the shaded region, this value, negative 1.53. So we fail to reject. We do not reject the null. So the data do not provide sufficient evidence to conclude the alternative. What is the alternative? Mu is different from 30, or mu is not equal 30. Yeah. That's correct. Okay, so let me clear all the drawings. So this is similar example. This is also two-tailed, so I'm not going to go over this one. Okay, so the recommended dietary allowance RDA of iron for adult females is 18 milligram. I think we went over this problem in the lecture class, and I also recorded the lecture. So I think you can, I think it is, we went over this one on last Tuesday, I guess, yeah. Or maybe in previous week. So here I can just give you the steps and how to solve this one, but I'm not going to give you the complete solution of this problem, okay? So first you need to state the hypothesis. So what do we want to test here? So we want to see whether preliminary data analysis indicate that applying, okay, whether that adult females are on average getting less than the RD of 18 milligram. So the null will be always equal. The hypothesis value is 18, and we want to see whether mu is less than 18 milligram. Yeah, so this is our hypothesis. Okay, compute the test statistic. So now you need to compute the test statistic. The observe, which is x bar minus mu 0 sigma over square root of n. So you have all the values. So what is the sigma? Sigma is 4.2. And what is x bar? X bar is 14.64. And what is the value of n? N is the sample size. And what is the sample size here? The sample size is, okay, so we have the data. So we can just count the sample size. So here we have the data. So how many observations we have? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have total 45 observations. So that's mean this is for n is 45. Okay, so mu 0 is the hypothesized value. So whiz is 18 milligram. So now we have all the information. We have all the values. So you need to just plug in these numbers here. So 14.64 minus the hypothesized value, which is 18, and sigma is 4.2 divided by a square root of 45. Simplify this one, you will get the test statistic. Okay, then you need to find the critical value or p-value. And if you find p-value, compare with the level of significance on %. Or if you find the critical value, compare the test statistic and the critical value and make your decision. Okay. So let me clear all the drawings. Okay. So let's move to the next problem. Okay. Suppose the mean height of women aged 20 years or older in a certain country is 62.2 inches. 100 randomly selected women in a certain city had a mean height of 61 points. So the sample mean is, okay, the sample mean for a city is 61.7, and the population mean for that country is 62.2. Okay, so at 5%, alpha is 5%, so that's mean this is 0.05. So we need to see whether the data provides sufficient evidence to conclude the mean height of women in the city differs from the national mean. So what was the national mean? National mean is 62.2. So we want to see whether the city mean is, so this is not mu, so whether this is mu 0 actually. Yeah, we want to see whether mu is different from this one or not. So that's mean the null will be then mu is 62.2, and alternative is we want to see whether this is different from the mu is the city mean, which is different from this one. We want to see this. Okay, so this is also two-tailed test. So we have all the information. So we have sigma as well. So what is the sigma? The population standard deviation is 4.4 inches. So this is the population standard deviation. So we have the sample mean, we have population standard deviation, we have the hypothesis and hypothesized value, and we also have the sample size. N is the 100 randomly selected women. So that's mean the sample size is 100. So we have all the information. You can, so this is also two-tailed test. So that's mean the null will be equal, and this value is 62.2, and this one will be not equal, 62.2. Oh, I'm sorry, 62.2. Okay, so let me check the answer. Yeah, that's correct. Then calculate the test statistic. So using the formula, Z observed is x bar minus mu 0 sigma over square root of n. You have all the information. Plug in all the numbers here and simplify it. Okay. Then you need to make the decision and conclusion. I'm not going to give you the complete solution for this one. Okay. So this problem is Sterry addressed the question of whether the mean body temperature of human is 98.6 degrees Fahrenheit. The researcher obtained the body temperatures of 93 healthy humans. So the sample size is 93, which are in the accompanying data set. So we have the data set compiled pairs A through C. So we have the data set here. Yeah. Okay, so you can open the data set in a spreadsheet, I guess. Maybe not. Yeah, here. Open in Excel. So you can open in Excel so that you can easily calculate the standard deviation and mean. Okay. Because you need the standard deviation and you need the mean to do the hypothesis test. Okay, so obtain a normal probability plot, box plot, histogram. So first you need to obtain a normal probability plot. So choose the correct normal probability plot. Okay, so you can use the Excel sheet to construct this. Then you need to plot the box plot, then histogram, then stem and leaf diagram. Okay, so we did it before our first exam, this type of things like the box plot, histogram, and stem and leaf. So I'm not going to go over this one as well. Or maybe for this exam, you can, because we didn't discuss the quantile plot. So maybe you can skip this problem. Yeah. Okay, so here, first you need to determine the hypothesis. So how do you determine the hypothesis? We want to see whether the angle between the body and head of an alligator during a death roll is greater than 42 degrees. So that's when this is right tilt test, right? Because we want to see whether mu is greater than 42 degrees. And we have the sample standard deviation, 13.647 degree. And we have the X bar, which is 48.82 degree. And what is the sample size? N. N is the number of alligator. So we have the data. So you can count the number of alligator. And then you will get the sample size. Yeah, so we have 2, 4, and 1, 2, 3, 4. So 20, total 20 observations. So that means the sample size is 20. Okay. So we want to, so this is right tilt test, we already know. So that's mean this is mu is equal. We want to see whether this is 42 degree and this is mu greater than 42. Oh, I'm sorry. This is 42. Yeah, that's correct. Okay, so now we will be using t-test. Why? Because we do not know sigma. We do not know the sigma value. We know the sample standard deviation. So you have to use t observed is equal x bar minus mu 0 s over square root of n. So that's mean you need to find the x bar. What is the x bar? 48.82 minus okay, so let me erase this per. Okay, so minus the hypothesis value, which is 42. So this is 42 and standard deviation is 13.647 divided by square root of 20. Yeah, this is the test statistic. So this is 48.82 minus 42 divided by 13.647 times square root of 26. Oh, no, not 26. This is square root of 20. So I found 2.5482. So we need round to 2 decimal places. So this is 5.55. 2.55. So the test statistic is 2.55. So let me check the answer. Oh, that's not correct answer. Okay. Okay, so let me do it again. So this is 48.82 minus the hypothesized value is 42 divided by the standard deviation is 13.647. Square root of how many observations do we have? Okay, let me, oh, okay, so I did, oh, no, this is the t-table. This is not the number of observations. 2, 4, so 1, 2, 3, 4, 5. So we have 20 data. Yeah, that's correct. We have 2, 0. Okay, so I didn't get actually 2.54. I got different number. I did mistake here. After simplifying this, actually, I got 2.2349. So that's been 2.23. So this is actually 2.23. Yeah. So it should be 2.23. Yeah, let me check the answer. Yeah, now that's correct. Okay, so since this is right tail test, the critical value will be this one. So how do we find the critical value? So let me erase everything. Okay, so the critical value is T alpha, and we need for T distribution, we need the degrees of freedom, which is n minus 1. So that's mean 20 minus 1, which is 19. Okay, so alpha is, what is the level of significance? 10%. So this is 0.1. So you need these two values, these two pieces of information, 19 and 0.1. So 0.1 is here and degrees of freedom is 19, which is here. So the test statistics is 1.328. So this is the critical value. I did mistake. The critical value is 1.328. Okay, so we need to write down it 3 decimal places, up to 3 decimal places. So that's mean it will be 1.328. Let me check the answer. Yeah, that's correct answer. So we have the test statistic. So the test statistic is, this is 1.328. So this is the critical value. So this is our rejection region. So the test statistics 2.23 is somewhere here. So who is in the rejection region? So that's mean we reject the null hypothesis and the data provides sufficient evidence to conclude that the population mean is mu is greater than the hypothesis mean, is greater than the hypothesis mean. Yes, that's correct. Okay, so this is also a similar type of problem. This is also t-test. So, but first I can just tell you whether it is right tail test or left tail test. So what do we want to see? So the ankle, the ABI compares the blood pressure. Okay, the ABI is, a healthy ABI is 0.9 or greater. Okay. So in the study research obtained the ABI of 187, the sample size is 187, so N is 187. The results were a mean ABI of this, so X bar is 0.87. With a standard deviation is 0.15. Alpha is 10%, which is 0.1. So do the data provide sufficient evidence to conclude that on average, the women with arterial disease have an unhealthy ABI? Unhealthy means, healthy means ABI is greater than mu is greater than equal 0.9 means healthy. So unhealthy means mu is less than 0.9, right? So that's mean the alternative is mu is less than, this is left tail test, and the null is mu is equal 0.9. Okay, so this is actually left tail test. So let me check. This is equal. So this is 0.9. This is 0.9, and this is less than. Yeah, let me check the answer. Yeah, that's correct. So now I need to calculate the test statistic. So you know that T observed is x bar minus mu 0 is over square root of n. So plug in all the numbers here and simplify it. You'll get the test statistic, and from the table, you can find the critical value. So then you will compare the critical value and test statistic. Here, the degrees of freedom is 187. Sorry, 186. So 186 actually close to 200. So you do not need, for this one, you do not need the exact degrees of freedom. You can just look at 200 because 200 is close to 186. And T alpha alpha is 0.1. So that's mean it will be 1.286. So it will be 1.29, I guess. Or oh, this is test statistic, not critical value. So you need to simplify it. Simplify this formula, x bar minus mu 0 s over. Okay, so let me put 0, and 0 is not correct, but after final check, we'll get the correct answer. So this is negative 2.73. Okay, so the critical value will be then 200 and 0.1, so negative 1.286. So it will be negative 1.286. You can see here, this is minus 1.286. So do we need 3 decimal? Yes. We need 3 decimal places. Yeah, that's correct. Okay, so we have the test statistics is negative 2.73. So if we draw the normal curve, this is left tail test. This is our negative T alpha. This is our critical value 1.286. And the test statistic is negative 2.73. So it is somewhere here. So that's mean it is in the rejection region. So we reject the null hypothesis. We reject the null hypothesis. So the data provides sufficient evidence to conclude that the arterial disease have an unhealthy ABI. Yeah, so that's correct. Okay, so now we'll discuss about the hypothesis test for 2 population mean, the difference of 2 population mean. Okay, so I'll actually record another lecture and where I will discuss this problem. So this is from chapter 10. So I'll discuss chapter 10 separately. So I'll stop here.